In today's session, we're going to continue on the implementation series on how to achieve breakthrough improvement in performance in your organization. So this is the 5 focusing steps that we've been doing the last couple video series. And this one's going to be step 3 of the 5 focusing steps of subordinating everything to the constraint. So to me, this is the most difficult one to do, and it's probably the one that most companies skip in doing. And then what happens is if they move to step 4, elevate the constraint, and the constraint moves, then it throws the system in chaos. So there's a misconception out there about find the constraint, unblock it, find the next constraint, unblock it. That's not the correct process. The correct process is identify the constraint, decide how to exploit it, and then fix it in a single location. The system can't handle the constraint shifting every few months. So we need the constraint stabilized in one location and keep it there. So subordinate becomes a very important step in keeping the constraint fixed in the organization because everything's going to be subordinated to that constraint. So what does subordinate mean? So subordinate means that once the constraint has been identified, the decision to exploit the constraint has been determined. Subordinate means that doing everything to make sure that the constraint can be highly effective. So there's 2 important steps in the subordination step. So number 1 is understand the effect of the actions to exploit the constraint and then on the system, and then ensure that all of the parts of the system align their action priority and support the performance of the system constraint. So this first step is the one that companies don't do. If we decide how to exploit the constraint and we're going to open up the constraint capacity, how does that affect the rest of the system? This is an important step to do so we don't cause the constraint to shift and put the system back in chaos. So when we talk about protective capacity, so we've talked about this significantly through the series about creating protective capacity. So the protective capacity is the capacity that all resources have above the constraint capacity. And so if we decide how to exploit the constraint, what we're doing is we're going to say, okay, how do we get more out of this resource? We're going to increase the capacity of this resource. So before we elevate, which is step 4, we want to make sure what's the effect on the rest of the system. So if you can see, if we elevate the constraint here, what's going to happen? Our protective capacity goes down. So our protective capacity, especially in operation 5 here, goes down significantly. And my rule of thumb is minimum 20% protective capacity. So depending on how much variability is in the system, 20% minimum. If you have more variability, more than 20%. So in this case, you can see the protective capacity went down significantly. So before we elevate, we're going to take this resource 5, we're going to increase that capacity of that resource to create sufficient protective capacity to protect the system. This is extremely important step to take before we elevate. That's why elevate is step 4. So now when we have this sufficient protective capacity, so we're going to go to operation 5, we're going to figure out how to get more out of that resources capacity to create the protective capacity before we elevate. So that's the first thing to understand. The second thing to understand, ensure that all of the parts of the system align their actions, priorities, and work to support the performance of the constraint. So because this constraint determines the output of the system, maximizing its performance of non-constraints is waste, right? So that's our definition of waste, is overproducing that don't help support the constraint. So subordination ensures that no resources overproduce and build unnecessary WIP. So again, we can't operate with zero inventory, right? There's a certain amount of inventory that's designed in the system as a shock absorber between supply and demand to overcome disruptions in the flow and disruptions to the processes. Second, make sure the constraint is never starved or blocked. Third, the system stays focused on flow, not local efficiency. So these are hard paradigm shifts and mind shifts for the company. So subordinate to this constraint, let's look at supporting functions. So for scheduling, for example, what's their new mode of behavior? Only release work at the constraint that can handle. Don't flood the system with work. Production, non-constraint resources will sit idle if they're running to the pace of the constraint. Quality, prioritize quality at the constraint over all other areas, and then any resource that may block the constraint or cause the load extra load on the constraint, such as scrap. So if we have scrap issues after the constraint and those products got to run through the constraint again, that's not a good thing. Okay, so quality has a priority. Quoting, commit to lead times based on the constraint availability, not overall capacity. Purchasing, expedite only what's needed to keep the constraint running. And lastly, maintenance, prioritize uptime and reliability at the constraint over other areas. And also from a maintenance perspective, those other areas, we're looking at critical resources. So critical resources mean that we don't have any backups, and if that resource goes down, it becomes a constraint. So we don't want to have that. So maintenance has a couple things. One, what are critical resources? Making sure critical resources stay highly reliable. And then any other resources that might cause starvation at the constraint becomes the priority. So that's our session for today. Again, connect with me on LinkedIn, visit our website, go to our YouTube channel where we have lots of videos on this type of content. Hope you enjoyed today's session.